So welcome to another session of Everyday Mathematics. Now, this is another season, yet another season. The MIT 2024 Integration B officially started today, and today is when the qualifying exams were done. So we do go ahead and give you the first 10 problems of the qualifying exams. And before I jump into that, I'd like to thank our subscribers. Thank you so much for the amazing support you continue to give us. We are growing and we do appreciate your support. For our first-time visitors, what we do here at Everyday Mathematics is we do go around, we look for seemingly harder problems, and we come back to you with the solutions that we think fit the problems. And so that's what we do. We do enjoy doing mathematics. For our repeating visitors, please, if you don't mind, pause the video and do subscribe to our channel. I would really appreciate your support. Now, problem number one is shown here. Problem number two, problem number three, problem number four, problem number five, problem number six, problem number seven, problem number eight, problem number nine, problem number 10. So quickly jumping into problem number one, which is the definite integral from x equals to 2023 to 2025 of a constant 2024. This is very simple. So what you do, you could just easily pull out that constant and you're left with the integration of one with the limits remaining as they are. So what the results there is an x as the integral with limits 2023 as the lower bound, and then the upper bound is 2025. So the difference between 2025 and 2023 is 2. And so 2 multiplied by 2024 is 4,048. We apologize for that mistake. So 4,048. Okay, so that's the first answer. Problem number two, which is the integral of x minus 1 to the power log x plus 1 over x plus 1 to the power log x minus 1. So for a variable x, this is the same as e to the power log or natural logarithm of x. So it's a function f x that is equivalent to e to the power natural logarithm of fx, right? So what we can do here is express the numerator and denominator independently in this formalism. And what we get is that the numerator is the same as e to the power log of x minus 1 to the power log x plus 1, and the denominator is e to the power log x plus 1 to the power log x minus 1. Now, for the rules of logarithm, we can take powers to which the logarithm is being taken, and we can take those powers to this constant position. And so what we have essentially in the numerator is e to the power, the product of log x plus 1 and log x minus 1. So is the denominator is the same as that. And so what you do is we cancel this and we're left with the integral of 1. And that means that the answer is x plus the constant c. So that's the answer. Problem number 3, which is the integral of x times log x plus 2x. What I could do here is I could pull x out so that we have the integral of the product of x and natural logarithm of x plus 2. And as you can see, I can express this x as the derivative of a half x squared. So using integration by parts, where the integral of this product is the same as uv minus the integral of u dv dx. right? So if our du, capital U, is half x squared, so uv is the same as half x squared times log x plus 2, and then minus, since u is a half squared and dv is 1 over x, so what we get here essentially is, as I said, a half x squared times log x plus 2 minus a half x squared times 1 over x, which is the derivative of log x plus 2. So since this cancels with the square here, we are left with this half x squared log x plus 2 times minus, the integral of a half x. So which means that our answer is a half x squared times log x plus 2 minus a quarter x squared plus c. That's the answer. Okay, well, you could simplify this a quarter by subtracting a quarter from 1, since a half times this 1 is 1, and so we have half x squared log x plus 3/4 x squared plus c. Now, number 4, which is the integral, sorry, there's no dx here, of the reciprocal of x log x plus 2x. A couple of things that can be done, this is not here, is that we can let u be equal to log x plus 2, and therefore du dx is 1 over x, and x du is equal to dx. And so therefore we can substitute for log x plus 2 with u, and just keep x here temporarily, but we see that this x cancels out with dx, since when you substitute for dx, we have x du. So we're left essentially with the integral of 1 over u, which is the same as natural logarithm of u plus c. And since we know u to be log x plus 2, we just plug that in, and the answer is the natural logarithm of log x plus 2, the natural logarithm of natural logarithm of x plus 2. And that is our answer. And then problem number 5, which is the integral of from x equals to 0 to 2 pi over cosine of sine x. And so what I could do is let u be equal to cosine sine x, and therefore cosine u is equal to sine x. So negative sine u du dx is equal to cosine x. And therefore negative sine u over cosine x du is equal to dx. And so we can integrate this. We've kind of kept the limits out for a minute. We can now substitute this with u, so which is this u, and for dx we have temporarily inserted a negative sine u over cosine x du. And we can continue saying that pulling out the sine u over sine u over, u times sine u over cosine x is the same as u over sine u over 1 minus sine squared x, since that's what cosine x is, the square root of 1 minus sine squared x. And sine x is the same as cosine u, so 1 minus cosine u squared, square root. And since this is the same as sine u is cancelled, and so we're left with negative integral of u. And that means that now our answer is negative u squared over 2 plus c, and we know what u is. So the answer really is negative half into bracket cosine sine x squared plus c. Now we're going ahead to plug in the limits. And since we have 0 to 2 pi, we just now substituting the limits, upper limits and lower limits. And so what this means is that when x is pi, cosine of 0, which is pi over 2 squared, which is pi squared over 4. And when sine 0, cosine of 0, we use 3 pi over 2 squared, which is 9 pi squared over 4. And so this is negative pi squared over 8 plus 9 pi squared over 8. And that is 8 pi squared over 8. And the 8's cancel. So the answer is pi squared. Okay. Another way is to just use a plot. Since this equation is really linear, in a sense that you have from x equals to 0, that means sine of 0 is 0, and so arc cosine of 0 is pi over 2. So we have pi over 2 here. And then it goes down at this point when x the value for which arc cosine is 0. We know that. That is pi over 2. And so that means that the value for which this in bracket is pi over 2. And then we have it increasing up to that point of maximum. And then up to a certain point like that. So this area here is what you can calculate. And I mean, if you know your values here and you know your values here, because these values are the same as this value. And so you can essentially transfer this side and you have something like a triangle, because essentially the missing triangle here is the same as this. So you have this triangle. And when you calculate the area of this triangle, I think you should get pi squared. Easy as that. Okay, now problem number 6, which is cosine x plus cotangent x plus cosec x plus 1 over sine x plus tangent of x plus sec of or secant of x plus 1. How to solve that is I could just expand that cosine x plus cosine x over sine x plus 1 over sine x over plus 1 over sine x plus sine x over cosine x plus 1 over cosine x plus 1. And so multiply the numerator to multiply through by sine x, and then the denominator by cosine x. So this becomes cosine x, sine x. This becomes cosine x plus 1 plus sine x, and then cosine x, sine x plus 1 plus cosine x. Then because this now goes up, we're multiplying across by cosine, so we have cosine up and then sine here. So this product here times this, but we realize that this numerator is the same as this denominator, so this cancel out. And so we're left with the integral of cosine x over sine x. And this, as you can see, the numerator is same as the derivative of the denominator. And that means that this is our natural logarithm of sine x plus the constant, integration constant c. Problem number 7 is x to the power 2024 minus 1 over x to the power 506 minus 1. What we can do there is we just use the difference of two squares. And so this here is the same as x to the power 506 to the power 4 minus 1 over x to the power 506 minus 1. And so it's the same as x to the power 506 squared minus 1 times x to the power 506 squared plus 1, and keeping the roots of the same. And so we can also expand this further. And so we have x to the power 506 minus 1 times x to the power 506 plus 1 times, and bracket x to the power 506 squared plus 1. As you can see, this and this cancel out. So we're left with the product of x to the power 506 plus 1 times x to the power 506 squared plus 1. And then we can expand that easily. So we're left with x to the power 15,018 plus x to the power 1,012 plus x to the power 506 plus 1. When we integrate that, we get 1 over 1,519 to the power x to the power 1,519 plus 1 over 1,013 times x to the power 1,013 plus 1 over 507 times x to the power 507 plus x plus the integration constant. That is our answer. Problem 8, which is the integral from x equals -1 to x, x equals 1 to x equals to 1 of 5x to the power 3 minus 3x squared. This is definitely an even function, so both the negative and the negative is a mirror of the positive, so we can just choose to say this is the same as twice the same integral, but from x equals to 0 to 1. And so we can expand that, so we get 25 x to the power 6 minus 30 x to the power 4 plus 9x squared. And so when you integrate that, we have twice times 25 over 7 times x to the power 7 minus 30 over 5 times x to the power 5 plus 9 over 3 x cubed, with the limits applied appropriately. Since 1 is the upper limit, that is the same as 25 over 7 minus 30 divided by 5 is 6 plus 9 divided by 3 is 3. So this is the same as now 2 times 25 over 7 minus 3. And this 7 times 3 is 21. So 25 minus 21 is 4. So 4 over 7 times 2 is 8 over 7. And this is our final answer. Problem number 9, which is the integral from 0 to 2 pi of sine x plus cosine x to the power 11. I can see what is happening here, since this is just, these are functions that oscillate between positive and negative, and we are integrating from 0 to the full cycle pi. The answer should be 0, but we can just spend some time and show how one could solve this. So inside the power of 11, we have a square root of 2 pulled out, and we have 1 over square root of 2 times sine x plus cosine plus 1 over square root of 2. So that when you multiply square root of 2 across, this still remains sine x plus cosine x. But we know sine x over 2, 1 over square root of 2 is the same as cosine pi over 4 or sine pi over 4. So this can also be expressed as pulling 2 out to the power 11 over 2 in bracket sine x plus pi over 4. So just from what we have here. And that is the integral, first over the constant of 2 to the power 11 over 2, integral from x equals 0 to 2 pi of sine x to the power x plus 4 to the power 11. So going forward, what one can do is now saying, hey, we can say let u be equals to x to the power 5, x plus pi over 4, and adjusting the limits appropriately. So we have a simple integral of 2 to the power 11 over 2 times the integral from u equals to pi over 4 to 2 pi plus 5 pi over 4 of sine to the power 11 u. And the same as sine u times sine 10 to the power u. And sine to the power 10 over u is the same as a half times 1 minus cosine 5u. And so we can multiply sine u through. So we have 2 to the power 11 over 2 over 2. Keeping limits the same, sine u minus a half. And this cosine 5u sine u can be expressed as a half of sine 6u plus actually minus, yes. Right, so that we're left with the minus here. So sine u minus this becomes positive. So what we have here is actually 3 over 2. Okay. And so since when we integrate sine u and sine 6u, this results into a cosine. 1 over 2 times 1 over 6 cosine u negative. Times the negative, that becomes a plus, and there we have 3 over 2 times a half of negative cosine u. But since cosine u is, or pi over 4 is the same as the cosine of 2 pi plus pi over 4. So these values, when integrated, just become 0. So we won't have to struggle. So we have the 3 here. We don't need to struggle further. We just plug in the 0 here. And that's the answer. Then problem 10, which is the integral from x equals to 0 to 2 pi of sinh x plus cos x to the power 11. So here we just have to expand in terms of the exponential function, which is the same as sinh is the same as e to the power x minus e to the minus negative x over 2 plus e to the power x plus e to the power negative x. And as you can see, these and that cancel. So we are left with just the integral of e to the power x to the power 11 from 0 to 2 pi. And that's the same as the integral of e to the power 11x. So that becomes 1 over 11 e to the power 11x integrated from 0 to 2 pi. And when you apply the limits, we have 1 over 11 times e to the power 22 pi minus e to the power 0, which is 1. So this is our final answer. So, well, those are just the quick proposed solutions for the problems, the qualifying exams for the year 2024. As I say, the integral or the integration B started on the 22nd today. And so tomorrow we'll go on and cover problem 11 to 20. And I think the actual regular season begins on Wednesday, 24th, which is interesting. Thank you for hanging out with us. We'll come back again tomorrow to share with you solutions for the other problems. Thank you. Until next time, bye-bye.